Good evening, I'm Twitty.
I am Minji. I'm Fasai.
Welcome to IMC 340 Feedback Control System, root locus. Start now.
For the first question, we want to find the root locus by hand. This is a transfer function. From the transfer function, you can know the number of pole and zero. You can find the pole by use the equation of asymptote, but you cannot use because these are the number of pole and the number of zero is equal. If you substitute in the equation of asymptote, you get infinity value both angle and sigma. Therefore, you use transfer function find the pole and you define the denominator equals 0. Substitute gs is equal this term and you can get the equation of k. Then you find the critical point or break in and break away. You must derivative of equation k by s. You can guess value of s and take the value of s, plot the graph. You can know the shape of the graph is circle, but you don't know the radius of the circle. And you can know the radius of the circle by this. You can take the value of s is a minus this term, and you can get the radius and plot on the graph.
After we have solved the first problem, the second problem is viewed in the table with the range of k in each type of response. For the unstable, there are no available in the range of k because there are no any pole in the right half plane as you can see. For the undamped, there are also none available because there are no any pole in the imaginary axis. For the underdamped, it is the range when the pole already leave real axis as you can see here, which is the 0.0718 until the 13.9. For the overdamped, it is root locus pad here as you can see, which is 0 until 0.0718 and 13.9 to infinity as you can see, which is not include the critically damped, the position that the pole start to leave the real axis as you can see here, which are only the two positions 0.0718 and 13.9.
From the last question, pick again in each case to plot unistep response. As you can see, the range of k is available in the underdamped response, overdamped, critically damped response. In the graph, this is a decay step response. First, overdamped response, we pick again k at 0.08, critically damped 13.9, underdamped response 80. So in summary, we compare our calculation to the MATLAB. In the MATLAB, match with our calculation. Actually, it is a circle. Next is this is a code used to plot the graph step response, which is matched with our calculation to